The recording has begun. Sam, feel free to share your screen and make sure we're all good to go there. I'm really happy to introduce Samantha Athey from the U of T. And are you about to do your defense soon?
Yeah, I have my first defense tomorrow morning.
Yay! Okay, great.
Yeah, I'm a bit nervous still, but I'm happy to do this. This will like ease me into talking about the same topic but in a friendlier environment.
Well, I'll be thinking of you. I'm going to be on campus.
That's great. So if everyone
Awesome.
can mute themselves, that would be great.
Yeah, I'm going to be on campus, and I will be thinking of you for sure. Are you going to be in the McDonald building doing it in person, or are you doing it online?
We're doing it in person, but we'll be in the Earth Sciences Center.
Okay.
Yeah.
I'll be right next door. So,
oh, really?
Yeah, let me know if you want to go to the faculty club. And
oh, you froze.
I'm sorry, if you want, I'm going to turn off my video, but if you want to go to the faculty club afterwards and celebrate.
Oh, thanks, Melanie. I would like that. That'd be fun.
Yeah.
Awesome.
So here she is, the amazing sustainable Sam that I told you all about. Carl also knows Sam's work because Carl's on our committee, Carl Mitchell as well. He's also a part-timer in McKellar, and he married into McKellar. So he's really stuck with us now. So thanks, Sam. Go ahead and take it away.
Hi, everyone. Thank you all for having me talk today. I'm a PhD candidate, but hopefully soon to be doctor, fingers crossed, at the University of Toronto, where I study the sources, pathways, environmental sinks, as well as looking at some solutions for microplastics in the Canadian environment. But today I'll be focusing specifically on I'll be sharing a bit of my research and the work of other my colleagues at U of T, and thinking about microplastic, specifically microplastic fibers in the Great Lakes. Great, let's get started. So y'all can see my slides all right? I'm assuming it's all showing up all right. All right, so microplastics refers to a diverse group of particles that we find in contaminating the environment. And these particles are obviously composed of plastics, but they actually are quite diverse, and they can come in all sorts of shape, example like polyethylene or polypropylene. But there are other types of particles in the environment that are anthropogenic that we also consider alongside microplastics. And these include non-plastic, anthropogenically derived textile fibers. So in a little bit, but other types of particles that aren't necessarily plastic, but that we also consider in the environment because they have anthropogenic sources, are actually tire wear particles, which are shed from our tires, and as well as paint tips and research. I'm investigating the sources, pathways, and environmental sinks of anthropogenic particles as a whole, but I specifically study one type, and that's the textile fibers, which is what I'll focus on for today's talk. And I'll get to it, but I'm also working to evaluate methods for reducing and diverting the emission of these particles to the environment. And so for folks that aren't really familiar with the term microfiber, it's a lot less common than microplastics, so you might not have heard of it, but microfibers are the small fibers that shed from the threads that make up our clothing, and other types of textile materials. And one of my favorite ways to illustrate this actually is if you look at, like, if you take your shirt sleeve, if you're wearing a long sleeve shirt and you hold up, maybe you can hold it up against the screen since it's a white slide, but if you hold it up against like a lighter background, you'll see textile fibers kind of protruding off of the material. And those are the size of the fibers that those actually exactly are the fibers that we're talking about. You might have also come in contact with these fibers if you've seen them like day, or they also are the main component in laundry lint. So laundry lint is composed of mostly these textile fibers. And so that's what we'll be talking about. And so each piece of clothing that you own contains trillions and trillions of these fibers, as you can imagine if you visualize them on your sleeve. But microfibers aren't just in our clothes. And in fact, they can be released from other fibrous materials as well, such as carpeting, furniture. You could probably look around your home right now and see a lot of different things made up of fibrous materials. And all of those things have the potential to shed those fibers into the environment. And I'll talk a bit about the non-clothing sources of microfibers as well today. And so just like our textiles, microfibers can be made up of a suite of different materials. And these include the microplastic or synthetic plastic fibers. Modified in different ways to give them properties that we like our textiles to have. And these include semi-synthetic and natural. But I'm really talking about not the straight off the sheep natural wool, but like the wool fibers that have been chemically processed and then made into wool sweaters. And so they're not really natural because we've applied chemical treatments to them, which changes their properties. And so when these chemical additives are incorporated into these fibers, they actually give them properties that are more similar to the plastic fibers. And that's why we are even concerned with them at all. And in fact, these chemical coatings can increase how long, make them more persistent in the environment, and as well as potentially influence the impacts that they have on the biota or species that ingest them. And so if you're familiar with microplastics, microfibers can consist of plastic materials, as I've just stated. So when people refer to microplastic fibers, we're talking about microfibers that are made up of plastic. But like I said, microfibers can also be made up of other materials. So when I refer to microfibers, I'm referring to the full suite of them. And basically they're any textile fiber that is anthropogenically derived, essentially. But microfibers are the most common form of microplastics that we find in the environment. And they've been found in almost every single environment on the planet, from water bodies near populated regions such as Lake Ontario, to recently, I think it was last summer, they for the first time, they documented microfibers on the summit of Mount Everest. And we've also widely documented them in polar deep sea sediments, and some of these environments are environments where humans don't go. So it's really interesting to see our materials, infiltrating these remote environments. And so not only do we have to be concerned about them being in the environment and everywhere in the environment, we also have found them widely documented in products sold for human consumption. So as an example here, they've been found in sea salt, beer, tap water. You've probably heard about microplastics in fish or seafood that people consume. But recently, they've also been documented in human tissues as well. But recently I saw a study that documented them in pet food, which is really concerning, but interesting. And so right now, I just wanted to quickly share with you the results of a recent study where we investigated microplastics and microfibers in sediments collected all across actually was a 2,200 kilometer transect across Canada. So it was the most extensive study on microplastics in Canada that has been completed to date. And we particularly were interested in fibers and what types of fibers were present where. But we looked at sediments that we collected from the Arctic, Hudson Bay, the Great Lakes, as well as lakes within the greater Sudbury area and the greater Toronto area. And we found that most microplastics across these Canadian water bodies are microfibers, which wasn't entirely surprising. But what was surprising is that approximately half of the microfibers that we were finding were actually not plastic. They were that anthropogenically modified natural fibers, specifically anthropogenic cellulose. So some examples of this would be cotton or rayon fibers. We actually even found fibers, they are technically cotton fibers, but we found fibers from blue jeans all through these water bodies, which was really interesting. And yeah, so sorry, my computer's a little slow right now. All right. And so it is well known at this point for both plastic and non-plastic fibers to be released from our clothing when we wash our clothes. And these fibers that are released during washing, they enter wastewater, which ultimately is transported to wastewater treatment plants. And in one of our studies that we conducted a couple of years ago, we found that we measured microplastics and microfibers in Toronto wastewater that was being discharged to Lake Ontario. And we found both plastic and these non-plastic fibers present in wastewater. And so this actually indicated that wastewater is an important pathway for these fibers to enter the Great Lakes ecosystems. And so from this work, we essentially know that microfibers are released from washing machines to wastewater. Wastewater acts as a conduit for these fibers to enter aquatic ecosystems. And then from other studies that we've conducted, we found that these fibers are then ingested by fish and benthic invertebrates as well in those ecosystems. And so this leads us to wonder, where's the solution? How can we mitigate these releases to the environment? And so I'm just going to cover a broad body of work that has been done on how microfibers can be diverted from the environment. So I actually didn't conduct all this research, but some of my colleagues at U of T did, and other researchers all around the world. Everyone is working very diligently on this issue to identify not only the sources, but potential solutions for mitigating these releases to the environment. And so, like I said, wastewater is a conduit for these fibers to enter the environment from laundering. But given the challenges and the costs of targeting microfibers in a wastewater treatment plant, for example, like treatment plant upgrades, it's not feasible. So we can look at upstream us, what we do and how our clothes, and then also how we design clothing in the textile industry. So I'll be speaking a little bit about both, but there's a large body of research that suggests that laundering habits can help reduce microfiber release during clothes washing. And so these are just a quick little list of what other researchers have found. But essentially, we know that quick cold water washes reduce the amount of microfibers that are released. Washing less frequently when possible. In fact, I learned recently through the study that we conducted on blue jeans, that your blue jeans, I had always been told growing up to wash your blue jeans after, like you can wear them twice and then you have to wash them. But Levi's actually suggests, and like other blue jeans manufacturers, suggest that you actually wash it at least maybe once a month, but if you don't wear them that frequently, like once every 6 months, because they're not made to be washed that frequently. It actually causes them to fall apart faster. And when they're falling apart, it's because they're losing fibers. And so that when those fibers are shed from that material, the material loses integrity. And so they fall apart. But yeah, so some other studies have also found that washing full loads of laundry can help reduce the amount of microfibers released. And we can talk about why this is in more detail if y'all want during the question section. But another really interesting couple of studies have found that front-loading washing machines compared to top-loading washing machines actually release less fibers. And it has to do with the amount of water that they use. And so apart from the behaviors and the best practices that we can do when we wash our clothes, there are also technologies or devices that have been developed to mitigate microfiber release during washing. And these include washing machine filters. So in testing one of the washing machine filters that's available on the market now, there are several. We looked at the Filtrol 160, but I think there are others in Canada. There's the Lint Lover, and there are a couple others. But anyway, we found that this filter works just as efficiently as the others. And these washing machine filters typically remove around 90% of the fibers in outgoing washing machine effluent. So, and to add to this, which is really interesting, one of my colleagues, Dr. Lisa Ertl with the Rockman Lab at U of T, found that not only do these filters reduce washing machine or reduce the amount of microfibers leaving your washing machine, they over time, if you deploy enough of these filters in a community, and they looked at 10% of a community having washing machine filters, they found a significant reduction in the amount of fibers leaving the wastewater treatment plant. So instead of costly upgrades, this actually, this study took place in Parry Sound. So instead of costly upgrades to the Parry Sound wastewater treatment plant that might not have been possible, by installing filters in just 10% of the homes connected to the wastewater plant, you can see here, they were able, after the filter deployment, they were able to significantly reduce the amount of microfibers that they saw leaving the wastewater treatment plant and entering Lake Huron, which is really, really good news. And so, interesting side note, these filters were not actually designed to mitigate microplastic pollution. They were actually originally designed by and for septic tank owners. And it turns out that lint and other debris that can leave the wash, things like pieces of metal and whatever can come off during the wash, these can cause blockages in the septic tank drainage field, and those are obviously costly and inconvenient to repair. So the solution to this was to develop a filter to intercept that material so that it can be thrown away rather than end up blocking septic tanks. And so it's always fun to learn that these filters were actually not designed to mitigate pollution, but they work very well at doing that. I'll talk about another device that it's the same line of thing. It's just a happy coincidence, but it works. And what's really cool, after the Parry Sound study completed, the results of that study, which showed that community-wide deployment of washing machine filters reduces microfiber emissions to local water bodies. More communities in Ontario, and I think beyond at this point, has made the effort to implement programs installing washing machine filters in household washing machines. And additionally, Ontario, and as well as other states in the US and other countries, are now considering or currently implementing legislation that would require microfiber filters in new washing machines. And what the funny thing is that there used to be filters in washing machines because electric dryers were not as common in households. But you need to remove the lint from your clothes. So they used to be in washing machines, but then they took them out when electric dryers became more commonly used, and dryers have a lint trap in them, or a filter. And yeah, so it's pretty interesting. So apart from that legislation, there's also been recent efforts to address microfiber pollution, in that the US has passed legislation with actually bipartisan support, which is pretty rare. And it will formulate the first federal or formal anywhere definition for microfibers. And this plan also is working, or this act also will require a 5-year plan for the federal government to address microfiber pollution. So they'll be looking at the sources of microfibers, not just clothing, but they will be looking at clothing and textile design and washing machines. But they'll also work to identify and address other sources of microfiber pollution as well. Because it turns out that clothes washing is only one source of microfiber pollution. And electric clothes dryers, as you can imagine, are another source of microfiber pollution from clothes. And it's estimated that clothes dryers actually release 2 to 3 times more microfibers than washing machines. So most, as you're probably familiar, most electric dryers have lint traps in them. And these are the exact same premise as the washing machine filter. It's a filter in your dryer and it captures microfibers in the form of lint, right? And we clean this out every time we do run a load of, hopefully every time, otherwise it might be a fire hazard. But every time we do a load of laundry in our dryer, we clean this out. So we're familiar with this. But what's interesting is these filters only capture, it's variable, but they don't capture everything. They only capture between 20 and 70% of outgoing lint. And that still equates to, trillions of fibers being discharged to the environment annually from your dryer, even though your lint filter is working. And you could probably see this if you have dryer duct vents that vents to the outside of your home. If you've ever seen how dirty that vent gets with like lint and small fibers, that's what we're talking about. Also, if you've ever cleaned the dryer duct in your, like, connected to your dryer, that you have to clean it because it starts to get blockages of lint, and that lint is just fibers waiting to go out into the environment. And so in a recent study in Parry Sound, we found that secondary dryer filters installed to the exhaust ducts of electric dryers can also effectively divert additional microfiber release to the environment. So they can work in partnership with your primary lint filter, the one that you clean out every time, and you can capture more lint that way. Funny enough, this device was also not originally intended to mitigate pollution. They actually, so this device is actually still marketed, and its main purpose at this point is to reduce, to improve your dryer's drying efficiency, as well as to reduce the risk of fire due to lint blockages in your dryer duct. But our findings suggest that these also can be an effective, like, additional point of capture for microfibers being released to the environment from your dryer. But washing machines and dryers are just 2 sources of microfibers associated with your clothing. Another major source is the release of microfibers from wearing your clothes. And so a recent study found that the release of microfibers to air just when you wear your clothes and walk around. And in the study, they had people like dancing in a room, and then they measured the fibers that came off of them. Like, they were doing all kinds of activities, but that part seemed really fun. But they found that the amount of fibers that are released when you just wear your clothes is on the same level as the amount that is released during washing. And obviously that's a lot more complex. You can't put a filter around you, right? So it's a lot more complex than installing a filter in your washing machine or dryer. But potential solutions to address this emissions pathway are being considered. And one of them, the textile industry is now working to determine what types of designs will provide longer lasting integrity to the material, so that less microfibers are shed during everyday use. So yeah, sorry. And then another source, so this is just, you're just going to keep rolling your eyes at this because these things come from everywhere. It's crazy. But another source of microfibers are the fibrous products that litter the environment. So we could take a walk outside, at least in Toronto, and you can see all of these things within like a city block. But one of the number one, not the number one thing, but one of these items are like sanitary products and wet wipes. So many of these products are marketed as flushable, and therefore they're flushed into sewage systems where they're thought to just be flushed, and then they degrade and they go away and we don't think about them again. However, they don't break down, and instead they cause blockages in septic and sewage systems. And when they do eventually make their way to the environment, they don't break down in the way that we think they do. They actually break up into these small fibers, and they just release fibers over time. Additionally, cigarette butts are another major source of microfibers to the environment. And a recent study actually estimated that approximately 300,000 tons of microfibers are released from littered cigarette butts annually. And cigarette butts are the #1 littered item on coastlines around the world, according to environmental cleanup surveys. The last one that I'll highlight here, but certainly not the least, is or the last, not in reality. Since the onset of the pandemic, we've been seeing an increasing number of face masks and other types of PPE, or personal protective equipment, littering the environment due to improper disposal practices. And so these masks are essentially exposed to the elements, and they start to break up into those fibers, and then they start to release the fibers into the environment. And so while washing machine and dryer filters effectively address one source of microfibers, we need more research and subsequent legislative action in order to develop solutions addressing these other sources as well. And there are other sources that I'm not talking about, like, for example, carpeting, because we really don't know how much microfibers are emitted from sources like that. We do need more research, and not only into how much they emit, but also the potential solutions for addressing those types of sources. But before I wrap up, I just wanted to share with you some of the efforts from the Rockman Labs U of T trash team working to address the issue. So for those of you who might not have heard of the U of T trash team, the trash team is pollution in our ecosystem. And the trash team most notably has helped implement research-based solutions to curbing microfiber and microplastic emissions to the environment. And this includes the studies that were conducted in Parry Sound, but it also includes another fun project, which I'll share next. But other members of the trash team are also working to improve waste literacy in the community through classroom education programs, as well as community outreach events, such as cleanups and presentations. And so one of the ways in which the trash team has been working to mitigate microplastic and microfiber release from littered items is through the Toronto Sea Bin program. And so sea bins are really cool. They're essentially floating trash cans. And it's crazy that someone only thought of this recently, but they're essentially floating trash cans. Oh, wait, I have the video will play. There we go. And they float on the water's surface, and they pump water through a mesh bag, similar to how the filter in the washing machine works, actually. They pump water, the surface water, through a mesh bag, and it creates a vacuum which draws in surrounding floating debris. And so in 2019, working in collaboration with Ports Toronto, the U of T trash team deployed several sea bins in the Toronto Harbor. And the Toronto Harbor was an important place to target because we actually see the highest concentrations of microplastics in the Toronto Harbor out of all of Lake Ontario. And so if you're ever down on the Toronto waterfront, you can actually see them. They're working 24/7, just pulling in garbage. And they're really cool to watch. And so the trash team has been monitoring the types and amount of litter that has been captured by the Toronto sea bins. And they found that each sea bin that they've deployed in Toronto has captured approximately 1,400 kilograms, or just over 3,000 pounds of plastic within a given year, which is a lot for a little floating trash can. And so most of these items include plastic fragments from like larger plastic debris that breaks down. Cigarette butts are really, really common. They've found microplastics, including microfibers, just floating in the surface water that gets trapped by the sea bin. Also styrofoam and food packaging is really common. But if you want to learn more about the CBIN program, I'm not directly involved with it, but it's really cool. Or if you want to learn about the other trash team's other work, you can go ahead and visit their website, or you can follow them. They're on Twitter and Instagram. They're pretty active. But yeah, I definitely encourage you to check out their work. And so with that, I just want to thank you all again for having me. And I'd like to acknowledge my supervisors and my collaborators, and I'll be happy to take any questions.
That was great, Sam. Really, really, really interesting. I'm just wondering, in terms of our role in the community, what do you think the most important message or messages would be for this Lake Stewardship Committee to take to the public in McKellar?
Yeah, I mean, I think the pilot study in Parry Sound was most interesting in showing that the washing machines, there's a large body of evidence supporting the fact that they are an effective means for diverting this kind of release to the environment. And we know that when they're deployed on a large scale, they are effective. So in terms of a takeaway, I think that that's probably the most important, like action-oriented takeaway from the presentation. But yeah.
Do you think,
Yeah,
because we're most of us are on septics, right? Like none of us are hooked up in McKellar to a water treatment plant. So I thought it was really interesting when you said that originally they were designed for use to prevent your septic field from clogging up, because that was something we were trying to figure out, is like, well, how much should we be worried? And so that's interesting that, you know, it could extend the life of your septic too. I see Al has a question too.
I have several actually. All right. Firstly, plastic, to get rid of it. If you burn it, you end up then the residue being microplastics.
Well, actually, you can burn plastics completely, but it produces toxic fumes. But to do that, it can be very toxic. But it is an effective means of removing microplastics.
Yeah. Okay. So the toxic fumes that are produced, can they naturally be broken down, you know, in the environment, whether they be microbes or what have you, like that?
Eventually, they can. Some of the toxins that are released from them, or they're called polycyclic aromatic hydrocarbons. They're a persistent organic pollutant. Yeah. So and they're quite toxic to humans as well, and the environment. And also have to keep in mind that we don't know a lot of the chemicals. Thousands of chemicals are used in plastics, and because of proprietary, we don't really know exactly what's in them. But from what we do know what's in them, they are persistent contaminants when they are released to the environment, so they do last quite a while.
Okay. Yeah. Okay. Second question dealt with throwaway, the filters being thrown away, and that's going back to, well, rather than throw them away, you know, you can burn them. I mean, there's a consequence to that, but maybe it's the lesser of two evils. The idea of a septic bed, which was talked about earlier, that in reality, the septic bed itself may be the filter that, you know, stops the stuff from going any further. And ultimately, as long as you don't go in there and disturb it any further, it'll stay in situ. Much like you find, I think it's phosphates that settle to the bottom of the lake, get buried and don't come back. Does that logic sound right?
Yeah, and it does. And if you think about it, when they're trapped by the filter too, whether you're on a septic system or wastewater, they you're diverting the release, so you're sending them to a landfill essentially when you're throwing them away. But it's better than being dispersed into the environment.
Yeah.
Yeah.
But I'm seeing the bed of the septic actually containing it, and unless that's disturbed, it won't go any further. It's not unlike dealing with radioactive material
Yeah.
and containing it one location. So
Yeah, sorry.
and the last one dealt with Arctic ice as a measure of historically when microfibers became an issue. Like, does it not serve like as a time frame? Should someone dig down there through the ice and check the content? And prior to, I don't know, prior to the Industrial Revolution, I guess, really.
Yeah.
So I'm wondering if you're aware of any research that was done on that.
Yeah, that's a great question. Actually, it's kind of funny because there wasn't work until recently, but they have looked at ice cores, and I think they were collected in the Antarctic, and they've also looked at sediment cores collected from the Pacific Ocean at one point, but also some freshwater lakes in the UK. And then they dated the cores to determine what types of plastics were present when. You have to give the fact that also there's a bit when the plastics are in the surface of the sediment, there is some bioturbation, so there is some mixing going on. But generally, they could actually tell when plastics started to become into use, because shortly after that, you start to see the appearance of microplastics in the sediment record or ice as well.
Yeah.
Pretty interesting.
Okay, those are just things I wanted some clarification on, and thank you for that.
No worries. Thanks for your questions.
Yeah.
I have another one if nobody else has a question. So microplastics in that non-natural, how inert are they in terms of when they're found in the flesh of animals, ourselves, fish? Presumably, I don't know if they get absorbed into plants that we eat or but I just wonder. I understand that they when fibers are treated with chemicals, and those chemicals then are carried into an animal through ingestion, that the chemicals themselves are going to potentially be a problem. But I'm wondering about the fibers themselves, if they just pass through or do they cause harm?
Yeah, that's a great question. And I didn't have time, and I don't personally research the effects of fibers, but my colleague who I mentioned before, Dr. Lisa Ertl, she has been, for her dissertation, she looked into the impacts of microfibers, both the plastic fibers, but also the non-plastic plant fibers. And she did find that while we do know in the research that has been done too, they do have that vector effect where they can pick up chemicals and they can potentially expose them to plants, plants and biota that happen to ingest them or inhale them. But a number of studies have started to find that the physical impacts of them, whether it depends on how they're exposed. So for example, we know from very preliminary research that has come out within the last year that inhalation of fibers by humans can cause inflammation in the lungs. We know from research that has been done on textile workers decades ago has shown that prolonged, first of all, microplastic and the cellulose fibers, so the cotton fibers, they accumulate in your lungs. They don't break down in your lungs very easily because you don't have the bacteria that are needed to really break those down very well. But in textile workers, they're exposed to a lot in the air, and they found that they can be linked to all sorts of lung issues. But if you think about it, asbestos fibers are also, they're not commonly used and they're banned in Canada now anyway, but that's another example. But Yeah, so the for humans, the health impacts are not well known at this point, but there is growing research on that. There's people are very interested in that. And in terms of for other organisms, they have shown effects in a wide variety of them, whether they're fish or animals. They have shown uptake by plants, but there's not too much research on what that what that causes effects in. But we do know that for common plants that we eat, they can uptake microplastics too. But yeah, so they've shown a range of no effects on some species to effects on reproductive issues, survival for other organisms, not for humans, but yeah, hopefully that research grows and we start to understand the effects on humans within the coming years.
Right.
I just want to add that humans are very difficult to study. We're complicated, and we're very messy experimental subjects. We also are very long lived, so it's hard to study us and attribute cause and effect, but it's also hard to follow people through a lifetime. Like now, actually, social media presence has made that a little easier, not losing people to follow up in clinical trials, but that's one of the reasons why animal research is valuable, and why we do research with creatures like zebrafish, for example, which are an excellent model system for looking at developmental effects of something that happens to an organism. And so one of the terms that you may be more familiar with is a lot of microplastics are endocrine disrupting chemicals. So they definitely have an effect on our physiology. Just because we haven't characterized that yet doesn't mean it's not happening. And I think this is a good time to be reminded of the precautionary principle, right? And in terms of like these chemicals come out, more clothes come out, and blah, blah, blah. You keep buying more stuff. The less stuff you have, the better, the more money you have. But if you buy some stuff that's slightly better quality, then that'll last longer too, right? So I'm wearing my mom's shirt that is 20 years old, but it was, a pretty good quality shirt. And I just love it. It's colorful. It's nice. Now the students must be used to it, calling it my Thursday shirt because I wear it every Thursday, but I don't care. It doesn't matter. And that's something really freeing. And also, not washing your clothes too much, like challenging your patterns, because we didn't used to wash our clothes every time we wore them. That's something that's happened with the advent of washing machines, and also with changes in gendered labor, all kinds of things in our society in the last 100 years. People didn't used to wash their clothes as much as we do now. And the scents and things that are in our detergents, and there's all kinds of like emotional plays that advertisers will really go for to get you to think, you're not a good mother unless your clothes smell like fabric softener all the time, and that, which is clearly has nothing to do with being a good mom, right? So there's a lot of complicated stuff out there where we won't know the effects on humans because we're just starting to measure it now. We won't know. Just like the asbestos story, it's a long latency, right? Figuring it out and measuring it, and then even then trying to untangle this complex chemical soup that we're all in, and what's causing what is really hard. But lab studies with animals is where we figure that stuff out. And often we do it with zebrafish because they're really tiny and they're really cheap, and people don't get too upset when we do experiments with zebrafish.
So one final question. It came up in our discussion in the committee the last month. So you have a washing machine filter and you empty it, and then what's the best way to dispose of that? All the microfibers that you're taking out? Do you send it to the dump? Do you put it in a plastic bag so it can't communicate with the rest of the atmosphere, or what's the?
Yeah, it's a great question. And I know people have different practices for cleaning their lint trap before the washing machine filters came along, but some people flush them down the drain. I would suggest not doing that because that kind of defeats the purpose for this from this perspective. But yeah, so what these filters essentially do is without them, you have the dispersion of these fibers into the environment or unless you have a septic system, and we're talking about washing machines, but for dryers, you have the dispersion of these things into the environment and we cannot recover them. At this point, we don't have the technology to take them out of the environment. So what we need to try to do is slow their release to the environment. So by being able to trap them in washing machine and dryer filters as much as we can, what you should do is throw them away to be put in a landfill, or I guess you could incinerate them. That would be an option. But yeah, and essentially just it concentrates them so they're not released and dispersed into the environment, and that way we have a handle on them. That's acknowledging that, you know, some of these fibers will still end up in the environment, but hopefully we can capture enough of them that we can help mitigate the impacts on the environment, because, you know, research is already starting to find that these are impacting ecological systems at this point. So yeah, that's kind of the best solution right now, but, you know, it could change. But yeah, so they're really a means of diverting release, but hopefully by capturing them, it makes, you know, because cleanup at this point is impossible really for most of the environment where these fibers are. They're too small.
Back to Rachel Carson.
Right. Yeah, Silent Spring.
Thank you very much, Sam. I really appreciate it, especially when you've got like such a big day tomorrow. So best wishes. I'll be thinking of you.
Thank you.
I've got a guest speaker for my class. I'm literally around the corner in my office. So,
yeah, I'll email you after I'm done.
Yeah, please do. Please do.
All right. Thank you all for having me.
Very best wishes. And I hope we were a good dress rehearsal for your presentation.
Yes, it really was. Thank you all for the opportunity.
Oh,
great. I hope you all have a good night. I'm gonna hop off now.
Yeah.
Bye, y'all.
Okay, thank you.
Take care.
We'll have a beer.
Yeah, I'm gonna see